All right. As if trig substitution wasn't enough, I'm going to show you another sneaky trick to solving um, some of these integrals using trig substitution in addition to completing the square. So so here we have another ugly looking integral that we really don't have any tools to solve yet. Um, But we can see in the denominator we have the square root of this thing, and it's not a nice constant minus x squared or x squared minus a constant. It doesn't fit our our forms that we've been using to for trig substitution. So, but we can take this denominator, essentially this quadratic in the denominator, and we can complete the square. Okay, so this may be something you haven't done for a while, but let me just show you, refresh your memory on how this works. We want to complete the square. All right, so I'm going to take this quadratic that I have. Now I would prefer actually to have a positive leading coefficient, so I'm actually going to write the this expression in the denominator as minus x squared minus 2x. Okay, so minus this quantity, right? So I'm gonna write it like that. Okay, so it's the same thing, right? I just pull the minus out front. Now, what do I need to add to this expression in parentheses to make it a perfect square? Well, basically you just take half of the middle coefficient and square it. So half of -2 is -1, squared is 1. Okay, so I'm adding 1 inside the parentheses. But I don't actually want to change the expression. I want to have the same value. So if I added 1 in the parentheses, then I have to do something to it to undo that. So, but because I have this negative sign, out here in front, what I really did is added a -1. Okay, so if I added a -1, then I have to add a +1 to cancel it out. All right, so now I've added 0. Now I've added 0. Okay, and so this expression right here is equivalent to what I had before, this part underneath the square root. It's the same thing. I've just basically added a -1 and then subtracted a -1 or added a +1. All right, so this is equivalent to what I had before. But what that allows me to do is then rewrite this as negative x minus, minus 1 quantity squared plus 1, which it probably looks a little better if I write it 1 minus x minus 1 squared. Okay, so now instead of the quadratic under the square root here, I'm going to replace it with this equivalent expression where I've completed the square. All right, so let's do that. So I'm going to have the integral of 3 over the square root of 1 minus x minus 1 squared. Okay. So, and then still the dx. So all I've done is I've replaced what I had with this new expression, which is equivalent. All right. Now I can apply trig substitution. So I've got 1 minus something squared. So, but instead of letting x equal sine, I'm going to let x minus 1 equal sine of theta. Okay? So I'm going to say let x minus 1 equal sine theta. And now if I differentiate both sides, I get dx is equal to cosine of theta, d theta. And now let's make that substitution. Now I'm going to actually bring this 3 in the numerator. I'm going to bring that out front. So I'm going to get 3 integral of 1 over the square root of 1 minus, and I'm replacing this whole 1 minus sine or sorry, x minus 1 with sine of theta. All right, so this becomes sine squared theta. And then times cosine of theta d theta. Okay? You see that? And isn't that slick? All right, and you can tell that this denominator is just going to become cosine theta, right? Now I could rewrite that. Well, maybe I'll go ahead and rewrite it. So this becomes 1 over cosine of theta times cosine of theta d theta. Okay, and then the cosines will cancel, and I just get the integral of 1 d theta. Okay, and that's just 3 theta plus c. All right, so now we have to convert back to x. Now I let x minus 1 be sine theta, so that means that I can I can solve for theta, right? Theta is equal to the arc sine of x minus 1. Okay, and so this then just becomes 3 arc sine of x minus 1 plus c. All right, and that's my answer. So there's one more, just another example of completing the square that I have to go through, and then you'll be able to work on the guided, or the discussion questions. But yeah, this next one's a little more complicated, so stay tuned for that.